Uranium recycling.
When you hear the word uranium, you might think of nuclear power plants, or radioactive waste that can kill you, or maybe even Homer Simpson holding a piece of glowing green material. And if you're like me and you like explosions, the first thing that comes up to your mind is probably exploding nuclear bombs. Though uranium is mainly used for electricity, and nowadays we use electricity for a lot of stuff. The problem is that uranium is limited and it doesn't last forever. And since we do use a lot of uranium will eventually run out. There aren't ways to fix this problem completely, but there are ways that you can do to slow it down. Ways such as recycling uranium, in which I'm going to be talking about later on in this video. In this video, I'm going to be talking about what uranium is, what are the uses for uranium, how uranium is extracted, problems caused by each extraction process, and how uranium is recycled. First, let's start off with what is uranium. Uranium is an element with an atomic number of 92. It is a metal used as fuel in nuclear reactors and produces energy capable of powering large cities and areas. If you wanted to find uranium, where would you go? Well, the best place to look is in silver mines, as there are actually 40 times more uranium than silver. There is also even more uranium than mercury. So if there is 40 times more uranium than silver, where is all this uranium hanging out? Well, it's actually scattered around in the dirt. There is a lot of uranium in dirt and seawater, but there is such a small amount that it's very expensive to extract. There are 3 different ways to get uranium. You can get uranium from open pit mining, underground mining, and in situ recover mining, or in short ISR. First is open pit mining. Open pit mining, also known as strip mining, is the removal of soil and rock near the surface to get an ore below. This type of metal extraction isn't only used for uranium but other metals as well, as long as the metal is close to the surface. This type of mining only works if the uranium ore is less than 120 meters away from the surface. Basically, the surface of the area is dug up and blasted. Underground mining. Underground mining is used when the uranium is too far from the surface to do open pit mining. The ore is drilled, then blasted to create debris, and then transported to a mill through a truck. Pretty much the same as open pit mining, but underground. After the uranium is mined, we still can't use the ore as fuel to create energy just yet, because in the ore there is about 99% of uranium-238, and uranium-238 isn't really that radioactive. And you want the enriched version of uranium, which is uranium-235. The ore is taken by truck to a mill where the uranium is crushed, then stored with acid, where it is precipitated. After you drain the acid, you store it again and then drain it again, and it repeats. After a while, you are left with something called a yellow cake. Yellow cake is used in preparation of uranium fuel for nuclear reactors, for which it is smelted into purified uranium oxide for use in fuel rods. The third method is in situ recover mining, or in short ISR. While not all uranium sources are extractable from ISR, it is the preferred method to extract uranium, as it is far cheaper to get the ores out of the ground, and it's more considered environmental friendly. In this method, water wells are drilled into the uranium deposit underground, and oxygenated water flows through the metal and literally rusting the rock that the uranium is in. The oxidized uranium is soluble, which means able to dissolve in water, and is brought to the surface and then extracted from the water through a treatment process. Now I'm going to be talking about the pros and cons of each mining method or extraction method. Let's start off with the open pit mining. A pro that the open pit mining has over underground mining is the efficiency over getting the uranium ores. Since open pit mining is done near the surface or at the surface, there is no space restrictions such as narrow tunnels. Open pit mining uses bigger vehicles to move around the ores, which means more uranium ores can be harvested in a day. Another pro that the open pit mining has over the underground mining is the greater safety. It is a lot safer in the open pit rather than underground because there aren't many hazardous issues. Moving on to the cons of open pit mining. One of the cons is the loss of ecosystem. An open pit mining operation practically eliminates any biological life at the surface. Vegetation is stripped and the surface at the dig site is left completely open. Without replanting and restoring the ecosystem, a strip mining site can take decades to recover. Abandoned mining pits can also pose extreme risks and problems. Without vegetation to stabilize the surface, landslides and rock slides can occur without warning. Another con that the open pit mining has is water pollution and drainage. Acid mine drainage, or in short AMD, is a serious problem that affects the environment. Any chemicals used to dissolve rock may fall into the local stream or groundwater, and it pollutes the water and poisons any living animal that lives in it. Moving to the pros and cons of underground mining. One pro that the underground mining has is unlike the open pit mining where a big chunk of surface is removed, underground mining can be hidden, having only head frames at the surface for entering or exiting, making the land which was used reclaimable for other uses. A con that the underground mining has is the safety. As there is no open air in underground mining, if there is gas leaks or any type of poison gas in there, it will severely hurt the employees who work on the ground, as maybe they aren't able to get out on time. There are also hazards such as cave-ins where the employees are trapped inside and unable to get out. Next is the pros and cons of in situ recover mining. One pro that this has is, unlike open pit mining or underground mining where there are possibilities to injure the employees that work there, in situ recover mining makes the employees completely safe and there are no hazards. Another pro is that there is no need to buy trucks or any type of transportation vehicles or explosive or drills. A con that it has is that it costs more money to make the facilities in order to do the in-situ recover mining. And also the leaching liquid that is used in in-situ leaching may leak and harm the environment if it gets to lakes or other water sources. Now I will explain why it makes sense to recycle uranium. It makes sense to recycle this metal because it would be less harmful to the environment if done so, and we would have a lot more electricity and energy. If we were to recycle nuclear waste, the leftover waste decays over 100 years or so, rather than decaying in hundreds of thousands of years as a standard nuclear waste would. Now I will be explaining about how uranium is recycled, and my method is a method that is now being developed and not used yet, but if it were used, the outcome would be incredible. As you may know, uranium rods make energy by transforming some of the uranium into different elements. Over time, the waste products, also called fission products, start to build up. After 4 years, the uranium rods are replaced with new ones. The old fuel rods, however, is dangerous to dispose of because it would be harmful towards the environment as the waste is still radioactive. And they take hundreds and thousands of years to decay. Uranium isn't the most common metal out there, and it's not very abundant. Therefore, the amount of cheap uranium globally would run low eventually. A way that scientists have been working on to fix this problem is to recycle the uranium waste and reuse it. As I have said before, the uranium rods generate electricity by transforming some of the uranium into fission products. Though the uranium waste that has been used still contains about 96% of useful uranium and only 4% of fission products. But since the unusable fission products are mixed with the usable uranium, we need chemistry to separate them. The process that separates the useful stuff, which is the uranium, and the unusable stuff, which is the fission products, is called pyroprocessing. This is a method that is still being developed by Argonne Labs. Pyroprocessing uses electrical currents and chemical reactions to separate the uranium and the fission products. The way that pyroprocessing works is first, we chop up the used fuel rods into small pieces and then put them into a vat of molten salt. When you run an electric current through the vat, the uranium and transuranics separate out and form crystals on the electrodes. Then we form new rods into newly recycled fuel and put them into a fast spectrum reactor, a reactor that lets us capture enormous energy that is still in the rods. By using this way, we can power cities for much longer. After the recycled uranium rods are used, the waste products can be formed into glass forms and safely stored underground. The method of turning the uranium waste into glass is called vitrification, where we mix the waste with sugar and put it into a heated rotating tube and then turning it into glass. Since this method is yet to be used, if we don't have any observable success rates of this recycling solution yet, though we might have some in the future. Though if we were to use it, we would impact this world a lot, as it would save the environment by limiting the decay time of the recycled uranium waste, because if it is regular uranium waste, it would take around hundreds of thousands of years, while the recycled uranium waste would only take hundreds or 100 to 300 years to decay. It would also supply us with decades and hundreds of years or thousands of years maybe with electricity, and this would be very useful towards us as we don't have to use real uranium but recycled uranium, and it will still work. The problem with this is the disadvantages with this process is that the solution that separates the used uranium from the waste uraniums requires a lot of money and supplies in which some countries don't have access to. Therefore, it can't be used on every country in the world. But still, this solution is still a very good way of recycling uranium and making more energy. My solution, which is pyroprocessing, mostly affects with the environment factor because the recycled uranium is reused and provides energy towards us, people. And by recycling the uranium, we would affect the environment by limiting the decay time of the recycled uranium waste and regular uranium waste, and potentially saving the environment, as the waste made by the reprocessed uranium is actually harmless rather than the waste of regular uranium, which is incredibly radioactive. You can't really use this solution for any other metal besides uranium because for other metals, for example aluminum or iron, you can put them into the recycling bins and they go to the companies, the recycling companies. They are going to be melted and then molded and then remade into the product and then used again. And mostly because the aluminum and iron is used for tools and uranium is used for energy, and that is very different from any other metals. Basically, my solution is to extend the period of usable energy in a uranium rod and trying to save the environment. I can't see why you would use this solution or method for any other metals because any other metals besides uranium don't produce electricity or energy. That about concludes it for my video. I hope you have enjoyed watching and hope you have learned something today. And please watch out for my future projects.